There we go. Beautiful. So it looks like everyone's in for the time being. So welcome back, everyone. Some of you are familiar faces. Some of you might be new. We are the Marine Environmental Education Center located out on Hollywood Beach. And today we are actually going to be talking to Stephen Kajiura, Professor Stephen, originally from Canada, and then made his way down here to become a professor of biological sciences at Florida Atlantic University. He does a lot of really cool shark research. Today he's going to be talking to us about shark migration. So very, very cool subject. We've done a lot of turtle stuff so far, so we're really excited to be able to get into the shark world a little more. If you haven't been here before, usually we hold questions to the end. So we are going to put everyone on mute just so you could hear him more clearly. And we will leave that group chat open. So feel free to write questions in that group chat while the presentation is going on. He'll go through it at the end to make sure we answer everyone's questions. Please try to keep it shark related. If you write a bunch of just hellos and things in there, he might miss a question. Otherwise, if you have any questions or concerns, throw it in the chat. Christina and I are also here to try and help facilitate any sort of issues you might be having. So whenever you are ready, if you want to take on over and share your screen. There we go. Oops. Oops, I think you're still muted.
Let's try that again. Can you guys see that?
Looks good.
Looks good. Do you see sharks milling around, a bunch of them sort of swimming around in the background? All right. So what this is what it looks like here in South Florida in the wintertime. From about January through March, we get huge numbers of these blacktip sharks that migrate down to South Florida, and they spend the winters down here. Now, what's fun about this is that we have a great opportunity to study this migration because you have so many sharks so close to the beach where we have nice clear water and we're able to see what's going on. And so what happens is we take advantage of the fact that there are sharks that come to us. We don't have to go anywhere. They come right down to South Florida to see us every winter, and it provides a great opportunity for us to study the long-term migration of these animals as they're migrating up and down the coastline. And so this whole project on the shark migration work, whoops, how does this go? Just a second. Started a number of years ago, over a decade ago now, because I would get calls from the local news media. And the news helicopters would say, look at all these sharks along the beach. What's going on? What, should we be concerned about this? And I don't know if you can see, I'm not even sure it's going to show up, but do you see my little mouse circling over here? There's people right there, standing there in their swimsuits, debating whether or not to go in the water. And then there's all these sharks just sort of milling around. And so this provides an opportunity for us to inform the public about what's happening. And it starts with this question: why are the sharks here? What's happening? And you can literally go down and walk along the beach, and like this guy who's walking along the beach, and I can count like a dozen sharks right there in the water, just off the beach where he's walking. Okay, so there's lots of sharks. They're really close to the shore. And in some cases, they're right up against the backs of these houses. You have a bunch of nice houses on the water with sharks in their backyard. And this would be a great opportunity for me. If I got to live in one of these houses, I'd have sharks in my backyard. It'd be fantastic. But some people are less impressed, and they want to know what to do about all these sharks that are milling down here. So we started a project, my lab started a project about a decade ago doing an aerial survey and figuring out what's happening with these sharks. We fly along and we count the sharks to see who's here, what sort of sharks they are, when they're here, and get an idea of what's happening with this seasonal abundance of these sharks as they come down here every winter. Now, these sharks are all blacktip sharks. Carcharodontis limbatus is the scientific name for these sharks. And these blacktips, they average less than 2 meters long, so not even 6 feet total length on average. Okay, So I'm 5'9". These sharks are average also about 5'9". They're about the same size as me. And what these sharks are doing is they are here, medium-sized sharks feeding on small bait fish. And we wanted to get an idea of how many were here, where they were distributed throughout South Florida, and when they were here, and where do they go when they leave. So to start this project, what we would do is take advantage of the fact that these news helicopters had great views from up top, and they'd be able to see the sharks along the beach, and that's what started this whole project in the first place. And so I figured, well, maybe the best way to study them is from the air. Let's look down from above and actually count the sharks as we fly along. And so that's what we started to do. We have an airplane, a Cessna one. I don't actually have it. I rent an airplane, a Cessna 172, and we fly along the beach with a video camera and a still camera mounted out the window of the plane. And so here you can see in the middle picture, there's the video camera bolted onto the window of the plane. Right behind it, there's a 35mm camera bolted onto the window of the plane. And on the bottom frame, there's my student Sherry. This was part of her master's thesis work, was counting the sharks along the beach. And what we would do is when we first started this project, we'd fly from Boca Raton up to Jupiter Inlet and cover all of Palm Beach County, all right, with this aerial survey. The plane would fly at about 500 feet off the water, nice and slow, about 80 miles an hour. You can't get much slower than that in this sort of airplane. With the cameras mounted out there, and the video camera would record constantly, right? The camera would just, from the time you take off until the time you land, it's constantly filming. And so you'd have this record, this video record of everything that you saw along the transect. And the 35mm camera would take one frame every 2 seconds. It'd go click, click, click. And it would take all those individual still frames that would act kind of like a backup in case anything went wrong with the video camera. And so we'd fly along from Boca up to Jupiter, and then subsequently we expanded our range, and now we go all the way from Miami. We go all the way from Miami Beach up to Jupiter. So now we're covering the whole Tri-County area from Miami, Broward, and then Palm Beach County. Okay. And so what we do is with these cameras mounted out the window of the plane, as we fly along parallel to the beach, what we're doing is we are constantly recording, and this is sort of the schematic, the representation of what's happening. You can see the plane up on the top there. You can see the beach with a little beach umbrella, the water with all the sharks in it. And what the camera is doing is it's aiming straight down, and it's capturing a field of view that goes from about the beach to about 200 meters offshore. And so I tell people to think of it this way. You know how long a football field is? It's about 100 yards, right? It's about 2 football field lengths, okay? So one football field backed up onto another football field, that's how far off we're sampling. So it's not very far offshore. And the reason is we want to sample where the people are. That's why we're flying along close to the beach, right where the people are, and seeing what sharks are there. And we know that there's more sharks out there. I mean, look on the other side of the plane that's not being seen in the Great Triangle, and we know there's more sharks. So the numbers we're getting are just a subset of what's actually there. Now, the nice thing is, down here in South Florida, at 200 meters offshore, the water's still pretty shallow. It's only about 4 meters deep, all right? So think of it maybe 12, 13 feet deep, not very deep. And because we have some nice clear water with the Gulf Stream coming in so close to shore here, it gives us the ability to see all the way down to the bottom. And so we can see the dark shadows, the dark spots of the shark clearly against the light sandy seafloor. And so as a result, we're able to count the individual sharks as we're flying along. And so just to give you an idea of what this video camera is actually seeing as we're flying here, this is a still frame lifted from the video. And you can see, well, at the top of the screen there, that's just a strut on the airplane. And at the bottom of that round thing is the wheel of the airplane. But in between, All those black dots that you see, every one of those is a shark, an individual shark. That is a lot of sharks. And if anyone were to guess, how many sharks do you think there are right there? You got 2 seconds, remember. That's it. You got 2 seconds to tell me how many sharks there are. Well, in that one frame alone, there are 1,678 sharks. And so clearly, there's no way you can count that. You cannot count that high in 2 seconds as you're flying along. That's why we need the video. With the video, we're able to take it back, download it on the computer, and then go through slowly, frame by frame, to make sure that we're counting every individual along the way, along the transect. And so what I'm going to do now is I'm going to show you the video from which this frame was extracted, just a little 30-second clip. This is an example of what it looks like as we're flying along. And so you can see the beach on the left side of the screen, you know, the strut and the wheel, and you can see all those little black dots in the water. All of those black dots, every one of those is a shark. All right. And as we're flying along, you can see that there's sharks. It just keeps going. Lots of sharks. You can see the reef there on the right, but there's a huge aggregation right there. And as you can see, there's no way you can count that in real time. You know, there's boats going by. Sometimes we see people on paddle boards in the water. Sometimes we see swimmers in the water. You know, we see lots of activity, people not even realizing that there are sharks right along there. And if you look on the left side of the screen, you can see the road, right? That's A1A, right? That's the Ocean Boulevard. So you can literally drive along and look out your car and see the sharks. They're that close to the beach. Okay. So the aerial surveys are really handy because it enables us to get this sort of top-down view and get a really good count of how many sharks are here in the wintertime, where they're distributed between Miami and Jupiter, and give us an idea of what these sharks are doing when they're down here. But the aerial surveys are only good for when the sharks are here. What happens after they migrate? What happens after they leave? You know, they migrate north in the spring. And if I go flying now, there's very few sharks out there. There's certainly nothing like the numbers you just saw. All right. And so the next step beyond looking at the aerial surveys was to start instrumenting these sharks with transmitters to look at their movement. Where are they going after they leave here? And so to do that, we use what's called an acoustic pinger, an acoustic transmitter. This thing is about the size of your middle finger. Okay, they're not particularly big, nice little things. They last for 6 to 10 years. It's a really long life on these things. And what they do is you make a little tiny incision in the body. You insert the transmitter into the body of the animal. You suture it back up again, just like you would with any sort of surgical technique they do on a human. We use the same surgeon's knots and everything. Okay, suture them back up, and now this shark has a little transmitter inside that's going ping, ping, ping. And that shark is swimming free and able to go on its merry way throughout its migration. And we're able to individually identify the sharks. Each one has a unique ID code. And with these individual little pingers on these sharks, we're now able to figure out where these sharks are, not only when they're here, but after they leave here, where do they go? Okay. So what's interesting is if you've got this shark making a little pinging noise with this acoustic transmitter, you need someone to hear it. You need someone to listen. And along the entire eastern seaboard of the United States and Canada, there is a whole series of these acoustic receivers, these listening stations. They're anchored to the seafloor. You can see the diver down there with the receiver that's anchored to the seafloor and just sort of suspended in the water column. We have floats on the line to keep it upright, and the receiver is tied to a rope. And so it just sort of sits there listening for any sharks with transmitters that swim by. And there are, like I said, there are literally hundreds of these receivers all along the coast, not just ours, but all the different researchers from the different universities and federal agencies and state agencies, everyone who has receivers in the water. We all share our data together. We all pool it together and say, hey, I heard one of your fish down here, and so says, I heard one of your sharks up here. And then we pool all that information together And so we're able to leverage this large array of these receivers along the seafloor. And so it looks something like this. Again, this sort of cartoon schematic where you have the float keeping the receiver upright in the water column. And now what happens is any shark that swims by that has this transmitter that's sending out a unique ID code, the receiver is able to hear it. It logs that information. It says shark number 12345 was here on this date and this time, and it stayed for, until this time. And so we have an idea of where these sharks are on these different receivers along the coast. And what we do is we go in about once every few months or so, we drive over, we scuba dive down, we bring the receiver up onto the boat, we download all the data, all the detections from that receiver onto our laptop, and then we scuba dive back down and put the receiver back under there again, and then we go home. And we're able to look and see who came by, what sharks were here. And again, it's not just our animals, it's any animals that that come by. And so the cool thing about this is with so many people having so many receivers in the water, we have a pretty good coverage all along the coast, and we're able to sort of piece together the movements of these sharks over long distances as they're making this migration. And so we're able to visually see them with the aerial surveys here. And after they leave, we're able to piece together their movements based on detections at various sites along the whole eastern seaboard. And with these long-life transmitters, we're able to look at their migrations over multiple years. So it's not just a short-term one up and one down. It's going to do that for the next 6 to 10 years. So these sharks are going to keep making their migrations up and down the coast, up and down the coast every year. And we'll be able to see those migrations year after year after year and get a really good idea of the movements of these animals. So the the acoustic transmitters give us a really long-term, it gives us long-term information on the movements of these animals. Well, the next thing that we have done to sort of supplement the information that we're getting from these acoustic receivers is deploy what are called satellite transmitters, all right? With the satellite transmitters, you do basically the same thing. You catch the shark, you bring it up beside the boat, you affix this transmitter onto the dorsal fin of the animal. And now what happens is anytime that fin breaks the surface of the water, the antenna on that transmitter is able to talk to an orbiting satellite up in space and get a GPS location, just like when you're driving in your car. It shows you a little map where you're going, right? The exact same thing here. It's giving us little points, little dots every time. And so now what we're able to do is piece together the movements of these animals even without a listening station. You don't have to have a listening post on the water listening for them. Now, as long as the shark breaks the surface of the water with its fin, that transmitter sends a signal to the satellite and you get a location, and you're able to piece together the movements of these animals. You're able to say, we tagged it here in South Florida in March in this example, and every one of those yellow dots shows a time that that fin broke the surface of the water and we got a hit, a location. And we're able to sort of connect the dots basically and see where it went. So from March until June, it went from Palm Beach up to Cape Hatteras, North Carolina, okay? And so that's great. It gives us information even without having to rely on a receiver. And the cool thing about the satellite transmitters is that it's real time. You don't have to wait until you go out and download the data and then report it. Basically, anytime that shark breaks the surface of the water, I literally get an email to say there's a detection. I can go in and check and see the latest location of that animal. So it's immediate feedback on the movement of these animals. So from the aerial surveys to the acoustic telemetry to the satellite telemetry, all of these have different advantages and different ways of informing us about the animal. And taken together, we've been able to develop an interesting picture about the migration of these sharks. Now, what's cool is these sharks have historically been reported to range from South Florida up to about Cape Hatteras, North Carolina. They go north of there only occasionally as a rare stray that wanders a little bit farther north, but that's basically been their reported historic range, okay? What we found, based on the telemetry work that we've done, based on the tagging and both the acoustic and the satellite telemetry tagging, we've found that these sharks are actually not just going to North Carolina. In fact, these sharks are going way up north, way up to Long Island, New York. It's a much farther migratory range than previously suspected, okay? So they're not just doing the short-term, this old sort of range that we have historically thought they did. They're actually going much farther than that. Now, whether that's due to the fact that we simply didn't know this before, or whether it actually is an expansion of their range, is still something we're trying to get a good, solid answer to. We lean more toward the fact that this is truly an expansion of their range, just because there are multiple lines of evidence beyond just our studies. Other people have found them farther north when they haven't found them farther north before. And so that really suggests that they are really going farther north now than they ever did before. All right. So now, the next iteration, where are we going from here? We've looked at aerial surveys. We've looked at acoustic telemetry. We've looked at satellite telemetry. What we want to do now is get a really fine scale idea of what these sharks are doing when they're down here. And to take advantage of that, we use something called a data logger. These data loggers are able to affix to to a package. And here you have, as you zoom in on that, you can see this little thing up here. That will record temperature and depth and light level and swimming velocity and 3-axis acceleration and magnetic heading and magnetic intensity. It records a whole suite of data. And at a predetermined time, what happens is that detaches from the animal. It floats to the surface. You can see that orange float package up there. It floats to the surface, and there are 2 transmitters on there. There's a satellite transmitter that gives us an idea of where this thing is bobbing around in the ocean. And there's also a VHF transmitter. It's a radio transmitter that gives us the ability to directionally locate this thing when it's floating around, to see exactly where it is once we get to the general area. All right. And so what this does is it enables us to get a really fine scale identification of their behavior. What are they doing minute by minute? This is capturing a lot of information. So for example, are they swimming deeper during the day and then coming into the shallows at night? Or are they, they're swimming more slowly during the day and then speeding up and swimming around quickly at night? Are they swimming north and then turning around and heading south? All sorts of different information you can gather from these data loggers that inform us about the movements of these sharks. So this is the next iteration, what we're doing now with this work to see what these animals are really doing. And the final thing that we're starting to incorporate, well, almost the final thing, are drones. I don't know if you guys have ever flown an aerial drone, but they're a lot of fun. And they're relatively inexpensive and easy to fly now. And because of this, we're able to take advantage of the fact that you've got these sharks that are very close to the beach, and we're able to go out to the beach and launch our drone and fly it over and look down on the animals and get some really cool footage about what these sharks are doing. All right? We can either launch from the boat or launch from the beach, it doesn't matter. But we're able to film these sharks from above. And the drone is nice because it can just hover in place. You just sit there and film the animals. All right, you can't do that in an airplane, and you certainly can't afford to rent a helicopter, but drones are a nice inexpensive alternative. And with the drones, what you're able to do is get some really interesting footage to help tell the stories. Let's see if this video plays. You should see our boat driving toward the beach right now. You can see a bunch of sharks in the water right in front of us. What the drone does is it enables us to see where the sharks are, and that helps us to target our fishing. We say, okay, that's where the sharks are, that's where we're gonna go and drop our lines. And so with that, we see the sharks, we drive over there, we toss our lines in the water, we're able to catch the sharks much more efficiently than if you were just blindly throwing your lines into the water and hoping for the best. And so because these sharks are so close to the beach, you can see how close they are right there. Because they're so close to the beach in such shallow water where we're able to see them, we take advantage of that and fly the drone to help us target our fishing. And in addition, because you have these sharks in nice clear water like this, we're able to get some swimming information. You're able to look at the number of times they beat their tail back and forth per minute, right? This gives you what's called tail beat frequency. How often they beat their tail, for example. How quickly they're moving, for example, their swimming velocity. We're able to gather that from the drone as well. And so the drone is able to collect information on the shark's movements and the shark's behavior just by sitting up there, hovering and looking down. So that's another tool that we've added to our arsenal that enables us to be highly effective at learning more about the behaviors of these sharks. And now the final thing that we have are what are called block cams. It's literally just a concrete block with a GoPro screwed onto it and a float so we can find it again. And so all you do is you start the camera recording, right? You start the GoPro recording, you drop the block overboard, and it just records constantly. And so now anytime a shark swims by, the camera is going to record it, and it's going to have a nice little video to see who swam by, who came to visit, basically. And because it's just sitting there unobtrusively, you're not disturbing the behavior of the animals. You know, if you were a human in the water splashing around with a snorkel and a camera, they'd be very scared and scatter away. But because it's just a little, you know, non-moving inanimate object sitting there, the sharks don't even know it's there, basically. They just think it's a rock and they just sort of swim around it. And with this GoPro on a block, what you're able to do is get some really cool footage. You're able to see the sharks in their natural habitat, just swimming around, doing what the sharks naturally do. And you're able to get this sort of, you know, the fisheye view of what these large shark aggregations actually look like when you're underwater without actually disturbing the animal in any way. All right. And so again, these block cams are a great way to look at the animals, confirm that they're blacktips, confirm in fact that they're male blacktips, and look at the natural sort of behavior, also able to get tail beat frequency and swimming kinematics from these sorts of videos as well. Again, another method that enables us to learn more about the behaviors of these sharks. And so remember that this whole thing started when the news crews would contact me because they had people in the water, they had sharks in the water, they were very concerned. Should we be worried about all the sharks here? And, you know, based on this picture, you can see all the people on the beach, all the sharks in the water. And I just want to remind you and reassure you that, you know what, sharks and humans, for the most part, can get along pretty well. As long as we recognize that the sharks are in their home and we're coming to visit them and we be respectful of that. And for the most part down here, we have relatively few bites on people. It's largely attributed to the clear water down here. We simply have good visibility and the sharks are able to see that you're a person and not a little bait fish and you're not part of their diet. So they get out of the way and leave you alone. And so we're fortunate that we have such great conditions down here. Now, if this were farther north, off like Daytona area, New Smyrna, the water is much more murky. And so with all those people in the water and all those sharks in the water, you could imagine that there'd be a lot more potential for interaction where the sharks simply didn't know that that was a little bait fish. They might think, didn't know that was a human. You know, the shiny palm of your hand might look like a bait fish. And that's how people get bitten up there. But we have relatively few bites down here. All right. So I would encourage you to get in the water, enjoy it. For the most part, you're going to scare the sharks away. But if you do happen to see one, count yourself lucky. It's a good sign that we have lots of sharks. It means that we have a good, robust, healthy ecosystem that we're able to support these top-level predators. And so with that, I'm just going to wrap it up and acknowledge the Colgan Foundation. They've been funding this work for a long time, and they've enabled us to do all this work, the aerial surveys and the telemetry and the tagging and whatever else we've done. So thanks to the Colgan Foundation for funding this. And if you're on Instagram or Twitter, I encourage you to follow us. We are at Shark Migration. So go check that out. And also if you're on Facebook, you can check out FAU Shark Migration to keep up on the sort of work that we've been doing. All right. So with that, I've been chatting for the last half hour. I think I've chatted enough. Let me turn it over and stop the screen sharing and see if anyone has any questions about anything we've talked about here. All right. So Taylor, are you moderating or how do I see what's happening here?
If you open up the chat box, we do have a couple
there it is.
questions in there, which I'm happy to read off to you if you can't find it.
I see. I got you here. Okay. Please see the chats. How did the, okay, so the first question I have here is how did the pandemic affect the migration last winter? So it's interesting because number one, this winter in 2020, right, January through March of 2020, we had a really warm year. These sharks are not fond of that warm water, all right? And so they simply didn't come down here. We had very few sharks down here this year. So in that sense, we had fewer sharks down here. The sharks were basically staying farther north. So if you're up north, right, in the summertime, and you're migrating south to stay within your preferred temperature, if you hit your preferred temperature off Fort Pierce, there's no need to swim an extra 100 miles farther south, right? You hit your preferred temperature, that's where you stop, and that's where you spend the winter, right? And so we had relatively few sharks all the way down here in Palm Beach this year. And so with few sharks down here, they're more distributed farther north. Now, with the pandemic, a lot of the beaches were closed, all right? So very few people were at the beach. We had significantly fewer bites on people this year simply because there was no one in the water. There's no one in the water, you can't get bitten, right? And so in that sense, the pandemic actually reduced the number of shark bites in Florida this year. So in that sense, it was good, maybe, in one weird and tiny little way of looking at it. And so yeah, that's the answer, I hope, for Kiefer. Next question, can you distinguish sharks from tarpon? And would tarpon be there during the migration? Yes. Yes to both. Yes, we can distinguish sharks from tarpon. When you're in the air, the tarpon look very straight. Their bodies are very rigid. Sharks have this sinuous S curve in their body, all right? So as you're swimming, the tarpons keep their body straight. They wiggle their little tails, but their bodies stay straight. Sharks are curving all the time so we can see them and clearly distinguish sharks from tarpons. And we'll call that out as we're doing the aerial surveys as well. And would tarpons be there during the migration? Yes, they're there. They're here pretty much all year round. We see the sharks now, we see the tarpons now, and we see them, in the summertime as well as in the wintertime when the sharks are here. So we can definitely distinguish them, and yeah, they're here all the time. And next is Leisha. Why would they be expanding their range? So I think what's happening here is based on some of the other information we have, these sharks have a very narrow temperature tolerance. They like water temperature between around 21 to 25 Celsius, all right? So it's a very narrow band. 3 or 4 degrees is what they like, okay? We know the oceans have been getting warmer over the past several decades, and their preferred temperature now is found at higher and higher and higher latitudes than it used to be. That's why they're going farther and farther north. Their preferred temperature is now no longer found off North Carolina. Now in the summertime, their preferred temperature is found all the way off Long Island. And so that's why they're going all the way up there, and then they have to come all the way back down here again in the wintertime. So their migratory range has expanded dramatically. And that's why we think, with the change in water temperature, that's why we think the range is actually just shifting so they can stay within their preferred temperature. Okay. And Kylie, to everyone, do you think it's expanding due to increase in water temperature? Yeah, exactly, Kylie, that's exactly right. And Connor, how long are the data loggers on the sharks? The data loggers are high resolution short-term deployments. So they're there for a week at the most. All right, they're not there for multiple years like we see with the other transmitters. And so they're on the animal for about a week, anywhere from 48 hours to a week, and then they pop off. We go and pick them up out of the ocean, download all the data to see what the shark has been doing in that time. And kind of what fishing method do you use? We've used a couple of different methods. We use a long line. It's a long line with several 60 little individual branch lines on it, each terminating in a hook with bait. We've recently switched in the last couple of years. We've switched to what's called the Drumline, and this is an individual concrete block with a float and a hook on it. And we put out these individual blocks. And part of the reason is we're able to be very targeted with our fishing thanks to the drones, right? We're able to see that's where the sharks are, and we're able to drop these individual blocks right on top of the sharks and maximize our fishing efforts. So now we've just used drum lines to catch all of our sharks. The nice thing about this is if the shark gets caught, it's able to swim around on this line without tiring itself out too much. Sharks are usually solitary. Is the blacktip an exception? Good. Yeah, Leo, that's correct. There are a few sharks that are found in these large schools or aggregations. These blacktip sharks are one of them. Silky sharks, for example. Scalloped hammerhead sharks. So a few species are able to form these groups like this. And this is one of the few that actually does this. And you're right, most sharks are off by themselves doing their own thing, but these blacktips, they like to hang out in huge aggregations, as you can see. Do you use the migration information to help protect the sharks? The more information we get on the movements of these animals and what habitats they require, what's called essential fish habitat, the more we're able to help inform the National Marine Fisheries Service about the movements of these animals and say, you know what? You used to be able to protect these sharks up to North Carolina waters. You better start protecting them up to New York waters now, because based on our evidence, they're going much farther than we ever suspected before. And so, yeah, we are able to use these data specifically for these fisheries management plans to help to protect the stock of these sharks. It's critical for our work. We are very much shark conservationists at heart. Next theme, where do the sharks live? Well, they move around, right? And so in the winter times, they live down here. In the summer times, they live up north. I tell people they're like the snowbirds, right? The people who come down from New York every winter. So the people drive down from New York, spend the winters down here in Florida where it's nice and warm, and then in the summertime they head up north again. That's what these sharks are doing. It's the exact same thing. They come down for the winter, enjoy our nice, warm, beautiful Florida winters, and then they go back up north and enjoy their summers up there. So that's where the sharks are going. Do the drones have to be registered with the FAA, Freya? Yes, they do. And we have a couple of drones. I'm not only an airplane pilot, I'm also a drone pilot. And one of my students has also got his drone license. And so we have two of us who are licensed, FAA licensed drone operators. And we are very careful to remain within all the restrictions that come along with that. So yeah, all our drones are registered, and we're both pilots. What year did you record the most sharks and why? That's a great question, Gabriel. So we started this project we started doing aerial surveys in February of 2011. And that was also, 11 and 12 were the two highest years for shark abundance. We had the most sharks in those first couple of years. And what we've seen is actually a steady decline in shark numbers over the past decade. And as the shark numbers have gone down, what we've seen is a corresponding increase in water temperature. Water temperature goes up. And so that's why we've got this beautiful sort of inverse relationship. As temperature goes up, shark numbers go down, right? And so that's why I think it's such a strong, compelling story to say that the migration of these sharks is tightly tied to water temperature. And it really sort of lends credence to this idea that as water temperatures continue to increase, these sharks are going to continue to find their preferred temperatures at, you know, higher and higher latitudes, and that's why they're finding we're finding sharks going farther and farther north. All right. Yes, you're recording the most. What are some common reasons for shark bites outside of humans entering their homes? Does wearing jewelry have an effect on the encounters? Sure. So what happens is we are not part of their diet, right? Humans, we're not fish. We're not part of what they're supposed to be eating, and they don't want to eat us, right? What happens though is people get bitten when there's a mistake, all right? And what happens is if you have like murky water and say you're off Daytona and you're paddling around on your surfboard, the water's kind of muddy, and your hands are in the water, your feet are in the water, you know, the shiny palm of your hand flashing in the water might look like a little bait fish that's about this big as well, that seems silvery and shiny, right? If your hand is splashing in the water like this, the shark could think, oh, there's a bait fish, and come on and chomp and bite your hand, right? It didn't mean to bite your hand. It's not one, doesn't want to eat you. You taste horrible. But the shark is expecting to be a little bait fish. And so that's what happens. So if the conditions are poor, like poor visibility, where the shark might not be able to distinguish a human from a little bait fish, that's something that contributes. The idea of jewelry, again, it's the same thing. Jewelry is shiny and flashy, right? Like a little silvery little fish. And so the shark could very well see that little flash in the water and think, oh, there's a little shiny fish, and go for that. And that's how people might get bitten. So really, again, I would, you know, exercise some common sense. You know, if you see some guy fishing down the beach, right? He's got his rod and reel in the water. He's got bait in the water. Don't go swimming there, right? That odor is bringing in the sharks. If the water's really murky, probably not the best idea to go swimming there either, because the shark might not be able to distinguish who you are compared to a little fish, all right? So some of these reasons are why people end up getting bitten. And remember, the shark is not out to get you. It's out to get little bait fish. And if you happen to be in the wrong place at the wrong time and look like a fish, well, that's really unfortunate, especially for you who gets bitten. But that's, you know, remember, the sharks are not out to get you. All right. All right, Jennifer, can drones be used for beach lifeguards to monitor beaches on a regular basis? Are there any city, county projects addressing this? Oh, good question, Jennifer. I don't know if you're aware of this, but down in Australia, they've started to do this now. They have a program funded by, I think it's the state government down there, where they are flying drones along the beach as shark patrol, literally flying back and forth along the beach. And if they see a shark, it informs the lifeguards right away. Whoop, shark here. And they're able to fly the flag and say, you know, dangerous wildlife in the water, and inform the swimmers about it. And so, yes, down there, it is a program. It's not really taken off here yet, for whatever reason. It's a possibility. And I do know that in California, they've also started to do a smaller scale version of this, where they're flying drones along the beach, and scientists are working with the lifeguards to fly the drones and see when there's sharks in the area, and help to say, oh, you know, watch out for, you know, this beach, as we just saw a white shark there. Now, in Australia and California, it's more of a concern because you have big sharks like white sharks that could potentially result in lethal bites. Not just a little bite on your hand or your foot anymore. Now it can kill you. And so there's a lot more motivation to inform the public about the presence of these dangerous sharks. Here, it's certainly unpleasant to get bitten. You don't want it to happen. But, you know, these black tips, they're not going to kill you if they bite you. So it's just going to be a sad day for you that day. All right. Elizabeth, are there other shark species that migrate en masse the way the blacktips do? Yeah, that's a really good question. Now, we certainly know that other sharks do make migrations, all right? For example, one of my friends tags great white sharks off Massachusetts in the summertime. And we've had his sharks detected on our receivers down here at Palm Beach. So we know that these sharks are making these long distance hauls from Massachusetts all the way down to South Florida in the wintertime, and then head back north again. So it's not just the blacktips who are making these movements, other sharks do it as well. One of the reasons that this blacktip migration is so well studied or so well known is because these blacktips are hugging the beach. They're right up against the beach, right? And that's where the people can see them. And if you have people looking at the sharks, that obviously gets their attention. These other sharks might be migrating, but they're often, they're often deep water somewhere. No one knows, when they're around. So you could have like a sandbar shark. It's the same size, right? It might be doing the exact same thing. We don't know because we don't see it. No one's studying that in the same way. But we certainly know that other sharks are also doing these sorts of migrations. It's just not as obvious, not as apparent as these blacktips, because these blacktips are the ones right up against the beach. Sophia, what's your favorite part about your research? That's a great question. I like it all. I think one of the fun things for me is, since I'm a pilot, I love just getting up in the air and flying, right? And flying along is sort of combining my two loves, love of flying and love of sharks. It doesn't get any better than doing that, So you're flying these aerial surveys and counting sharks from the sky. We're the only program in the world that has this, this aerial survey, the shark aerial survey going. And so I think for that, it's just plain exciting, and I love it. So I mean, it's all good. I love the fishing. I love flying the drone. I love scuba diving and pull up the receivers. It's all good. But it's a great job. Let's just say that. All right, from Nicole. As a recently graduated undergrad, topics like these drive my interest in this type of field, these type of research fields. Although research in these areas seem to be quite competitive due to their nature. Yeah. Do you have some advice in regards to getting your foot in the door to such research, especially for a student from the landlocked state of Wisconsin? Okay. Well, Nicole, I was from a landlocked province in southern Ontario, Canada, not too far from Wisconsin, in fact, so I can sympathize with you. What I found when I was an undergrad, what I did is I did various volunteer programs in the summer. And what this did is it enabled me to get some research experience under my belt. And these were not, when I was a student, many, many moons ago, these were not paid positions. I basically volunteered my time to get that experience. And once I was able to get that, it made me more competitive in applying for other, like for graduate schools and things, to say, oh yes, not only do I have my degree in marine biology, I've also have experience, I know how to drive a boat, I know how to plumb a tank, I know how to ID fish, whatever. All these things that I had learned through these volunteer experiences sort of paid off in terms of getting me, giving me the opportunity to get in and start the graduate process. So that's what I would recommend you do. Invest some time and get some extra experience to make yourself more competitive. Add some skills to your skill set. Learn how, get small boat handling experience if you can. Take a field course if you can. Get some hands-on experience, get some volunteer experience to make your application stand out from the crowd. You're competing with a bunch of other kids who also have biology degrees and also done the same thing as you, also have good grades, fine. You all have that. Do something special, do something above. And that's what's going to make you competitive. That's what's going to give you the edge. All right. And from Elizabeth, why did you pick this job? I always wanted to. I mean, that's really it. When I was a little kid, just like I was saying to Nicole, I grew up in southern Ontario, Canada. I never saw the ocean. I used to watch like Jacques Cousteau specials or Wild Kingdom with Marlon Perkins, stuff like, this was before any of you were born. We used to have these shows when I was a kid, and I loved it. And so I wanted to be a marine biologist. And now you try to convince people from a small farming community in southern Ontario that you want to be a marine biologist, and they're going to say, you don't want to do that. There's no jobs doing that. But I said, no, I want to do this. So I did. And I actually got to do what I always wanted to do. Here I am studying sharks for a living. I mean, it's the ultimate dream for me. So in that sense, I picked the job because I wanted to do it, and I have absolutely no regrets. So if you want to do something, you feel passionate about it, just do it. Don't worry about people telling you, oh, you can't do that. No. If you want to do it, just do it. You'll be fine. Hopefully you'll be fine. Are there, that's all that I can see on this list. Are there any other questions? Anything else people want to talk about?
We will give everyone another minute if you think of any extra questions. Otherwise, if you think of them after the program, feel free to email them to us at meek@nova.edu. And if we can't answer them, we will be very happy to pass them along. But otherwise, thank you all so much for coming today. And thank you so much, Professor. That was an amazing presentation. Very, very cool. If you missed the beginning for any reason, we did record it. We are going to post it on our YouTube channel and all of our social medias and things later. But otherwise, thank you so much for coming today. This Thursday, we have one more presentation this week with Jillian Morris. She is the head of Sharks for Kids. So we are having a very shark-filled week. We will be talking about shark biology, conservation, and Sharks for Kids mission. So if you are free on Thursday at 1 p.m., come join us again. Otherwise, thank you.
Great. Thanks so much, folks.
Bye, guys.